Hi, today I'll be discussing 3D vectors. To start off, I'd like to go over regular vectors. In a two-dimensional vector, you have two components, an x and y component. Vectors have a magnitude and a direction. We can change their magnitude by multiplying by a scalar. Vectors can change their magnitude or length, yet they always remain in one direction. To find the magnitude of a vector, you take the root of the component squared. The dot product is a scalar. When finding the dot product, you are essentially applying directional growth from one vector to another. The dot product is found by multiplying the x component of the first and second vector, then adding that to the product of the y values in the first and second vector. If the dot product comes out as 0, no need to worry. This means that the vectors are perpendicular. The same goes for three-dimensional vectors. 3D vectors have an added z component. This is the aspect that makes the vector 3D. In order to find the magnitude, the steps remain the same, just adding another component. In vector v, if x equals 3, y equals 4, and z equals 6, to find the magnitude, you would square each component. 3 squared is 9, 4 squared is 16, and 6 squared is 36. The magnitude will equal 61. Square root. The steps to find the dot product remain the same as well. In vector v, if x were to equal a, y were to equal b, and z equals c, you'd multiply x times a, y times b, and z times c to find the dot product. As I mentioned earlier, vectors can be stretched or shrunken, but their direction always remains the same. Vectors can also be manipulated to being added or subtracted from each other. When adding two-dimensional vectors to three-dimensional vectors, the addition of a vector A and negative vector B are done end to end. Place the initial point of negative vector B on the terminal point of vector A. Then vector A and negative vector B is the vector which begins at the initial point of vector A and ends at the terminal point of negative vector B. For example, if vector A was negative 5, 10, and negative vector B was negative 2, 0, then after adding them, the new vector would become negative 3, 10. Now if we were to subtract the vectors 5 minus 2 and 10 minus 0, the vector would equal 7, 10. In an example problem, I'll be showing you how to find a missing component in a 3D vector to make the vectors perpendicular. Vector v equals 1, 2, 3, and vector u equals a, negative 2, 1. When solving for a, set it in the quadratic form and set the dot product equation equal to 0. To solve, we will multiply 1 times a, 2 times negative 2, and 3 by 1. After doing basic algebra, we will find that a equals 1. You should always check your work to ensure that if a equals 1, the dot product will be 0. 1 times 1 plus 2 times negative 2 plus 3 times 1 equals 0. After checking our work, we now know that the vectors are perpendicular. Thank you for watching. I hope you enjoyed your intro into solving three-dimensional vectors.